Good morning, students. Our today's topic is banking of roads. So what is the objective of this topic? We are going to see the role of friction when vehicle is moving on a circular track. What is the importance of frictional force when vehicle is moving with a certain speed? How many of you know that the speed of the vehicle in a circular path depends on the radius of curvature of the circular path and the angle of inclination of the outer edge of the road? These things we are going to study in detail. So we know that if any vehicle has to move in circular path or it has to take a turn in curved path, it needs centripetal force. Without centripetal force, no body moves in circular path. Then how this car is getting centripetal force when it is moving in circular path? So we know that without centripetal force, no vehicle moves in circular path. That means this vehicle is getting centripetal force. From where it is getting that centripetal force? We know that there is a frictional force between the tires and road, and that frictional force providing necessary centripetal force. Now we will see everything in clear. Here, vehicle, whenever it is moving on the road, the normal reaction on the vehicle by the road is always balanced by the weight of the vehicle. So we can write normal reaction N is equal to mg. We know according to law of friction, frictional force is F is equal to mu N. So we can write it as this frictional force is mu mg. So this is the static frictional force. And this frictional force only providing necessary centripetal force. So we can write if the maximum safe speed of a vehicle is v, then the centripetal force acting on the vehicle, we can write it as mv square by r. So as it is acting towards the center of the circular path, we call it as centripetal force. This centripetal force mv square by r, we will make it equal to the frictional force. Why? Because the frictional force only converted into centripetal force. So from this we can say that frictional force is equal or greater than the centripetal force, then vehicle moves safely without any skidding. So here I am writing frictional force Fc less than or equal to centripetal force we are writing. So frictional force we know already mu mg and centripetal force is mv square by r. So when we make them, we will get a formula for a velocity or the speed of the vehicle, that is v is equal to under root mu rg. When vehicle maintains this speed which is less than or equal to under root mu rg, it will not skid away from the track. Sometimes we know that due to floods or due to rain, so frictional force significantly decreases. In such case, how we have to move without any skidding on the circular track? For that purpose only, we are using banking of roads. Now, what is banking of roads? Banking of roads is nothing but raising the outer edge of the road to certain angle. That is only we call it as banking of roads. So when we raise the outer edge to certain angle, what happens? Even though there is no frictional force, in such case, the normal reaction component gives the necessary centripetal force so that it moves safely in the circular path. Now when you see this diagram carefully, here normal reaction we are dividing into two components. One component is n sine theta, and this component is towards the center of the circular path. And that's why I say this component is helping the vehicle to move in circular path. In other words, this component is converted into centripetal force because of which vehicle is moving in circular path. What about another component of normal reaction? The another component of normal reaction, n cos theta, is balanced by the weight of the vehicle. So the only component helping the vehicle to move in circular path is n sine theta. So I can write n sine theta is equal to mv square by r, where mv square by r is the centripetal force. Now, another component, as I told, n cos theta is balanced by mg, so we can write n cos theta is equal to mg. By solving these two equations, we will get tan theta is equal to v square by rg, where theta is angle of inclination. How much angle we raise the outer edge, that itself is angle of inclination. So tan theta is equal to v square by rg. From this, what is v? v is equal to under root rg tan theta. This is the maximum safe speed of the vehicle when it is traveling in a circular track without any skidding. It has to travel even though there is no frictional force. Then we use this formula. By seeing this formula, you can tell that the speed, the maximum safe speed, depends on radius of curvature, angle of inclination, and acceleration due to gravity. Thank you.